This picture book is the main points of the activities that were carried out in stages over 3 terms and 4 years up until 2003 by the JMA TZD Zero Defects and Claims with Mr. Shigehiro Kimura and his member countermeasures study group together with 21 companies from different industries and achieved results. In this picture book, several people appear as fictional figures, and I have compiled the contents of the activities and examples of the results obtained in the ZD study group, as spoken frankly by practitioners from a certain company, and put them into practice. I hope that these practical contents of the study will be of use to you. The birth of Judo, famous for its Olympic Games, is known to have been first systematized by Mifune 10th Dan. He developed modern Judo by experimenting with techniques necessary for practice based on the ancient Japanese art of Jiu-Jitsu. In a similar way of it, the TZD research group has extracted only the methods that make it practical to investigate the causes of defects, as organized in this table, and systematized them for use by various companies. In this picture book, I will introduce some of the most representative methods. Before explaining the method of fact-based cause investigation necessary to reduce defects to zero, which has been systematized by the TZD study group, I would like to briefly explain the difference between this method shown at the bottom of this figure and other methods in the industry. The top method is a method of assuming the cause of defects using brainstorming, which was widely used in TQC activities in Japan around 1970. The second method is also a method of determining assumed causes and occurrence mechanisms, and conducting investigations in order to prove a certain theory. The TZD study group does not use these two methods, but instead uses the third method, and this analysis method is an effort to embody the international principle that the 7 major principles of ISO 9000 advocate decision-making based on facts. In defect countermeasures based on the brainstorming method or academic theory, after coming up with many possible causes, measures that are likely to result in zero defects are implemented one by one until a correct solution is found. However, in this method, engineers from a certain company, SHO and AI, will take one problem and proceed with the fact analysis compiled by the TZD research group, by analyzing the physical mechanism of one cause that causes the problem based on the actual site and the actual product. Once the cause has been identified, the most appropriate solution will be taken to completely eliminate the cause. The difference between the defect countermeasures used by companies that have used this brainstorming method and the one problem, one cause, one solution method proposed by the TZD research group is as shown in the figure. The method of using one problem, one cause, and one solution to find the cause of defects and equipment failures by examining the actual site, actual object, and phenomenon is well known in the industrial world, not only for solving technical problems during NASA's Apollo program, but also for being used as why analysis at Toyota. This figure shows the why analysis used at Toyota. For more details, I would like you to refer to the picture book I will introduce this time, but there is another brainstorming style, why analysis in the industrial world. Brainstorming style why analysis is not covered in this picture book, but the format is as shown in the example in this figure. There are many books and seminars on this method, but since it is a measure based on assumed causes, SHO and AI are shown as examples in the picture book to warn people not to use it. In the TZD study group, we must not have people pretend to have actually performed a why Why? Analysis based on what they have assumed in their heads without actually analyzing the cause of defects as fact, as in the previous brainstorming style. Why? Analysis. So in this picture book we have shown the process by which SHO and AI are considering incorporating the analysis method, shown in this figure, into their own company. You can see the details of the analysis in the picture book, but you can see in this figure the why analysis that is created as a result, and the contents of the diagram illustrating the principles of cause investigation that are used. This case study is from when Mr. Nakamura instructed a company in the UK on why analysis. In this case, in addition to the previous analysis, video analysis was used to analyze the facts and to analyze the causes of product defects. This company also introduced how they used the TZD method to reduce all defects to zero in a short period of time. In this way, defects are related to physical phenomena, and one cause leads to one defect. The method of finding the facts is a physical scientific subject, so many measuring instruments other than video are used. In the picture book, there is also an example where a camera was used to look into a dust defect that had been considered a chronic defect, and a scanning microscope was used to successfully identify the cause, so please take a look. This figure introduces the concept of a method to identify causes by using comparative analysis developed by NASA, with one problem, one cause, and one solution approach. This method is famous for being able to identify the cause of the Apollo 13 explosion in just 15 minutes, through communication with space, allowing everyone to return safely to Earth. In this picture book, we have used case studies of actual incidents to provide a detailed explanation of the steps to logically derive most probably cause. The outline of the case study was taken up using this diagram as a model. The case involved a crater defect that occurred during the coating process of decorative panels. Unfortunately, the veteran engineer who had been working on the countermeasures had searched for the cause but was unable to solve it, which led to the customer halting delivery of production. However, after learning this comparative analysis and analyzing it, the cause was apparently identified in 2 hours. Whether you know about comparative analysis or not, this case showed the importance of this for people who do this type of work. Comparative analysis can be learned through case studies. The format shown here is the analysis sheet to be filled out when analyzing through comparative analysis, but for those who are interested in learning more, I recommend using picture books. Above, I have explained a small part of the Kindle picture book, Zero Defects through Mechanism Analysis. I hope that those who wish to use it will access this site.